Alright everybody, welcome back to the series. We're back here with the 350 Pontiac block. Today we're going to get this bored and decked. So first thing I'm going to do is go ahead and magnaflux the block, check for any cracks before we do any machine work on it, and then we'll get it mounted up on the RMC 1000 here, and we'll do our machine work.
As usual, this block has been baked and blasted clean so that we don't miss anything on the inspection, because you hate to find a crack halfway through the machine work.
You may remember in the teardown video I mentioned that we found a main bearing cap that was cracked. And what I'm referring to is actually this right here. This cap is cracked right there where one of the dowel pin, locating dowels goes for this cap. And basically this little piece was hanging off of there. Basically what they should have done is made sure that both of these dowels were aligned and that the cap was down tight on the surface here before they tightened the bolts down, but they failed to do that, and as a result they cracked this cap. The other thing they did is screwed up the dowel pin. Now this engine obviously ran an entire life after that, and there's no damage, there's no signs that this cap has been walking or anything like that. This cap will be okay. What we are going to do is replace that dowel pin. So I'm going to pull that dowel out and we'll put a new dowel pin in. And being that this cap still has over 50% of the whole material there to locate this cap, it's our opinion that it's going to be okay, because if you wanted to, say, find a new cap for this block or find a different block, you start to get cost prohibitive, and it's just not necessary.
The dowel pin was pushed a little bit too low into the block for me to grab with my usual dowel puller, so I built it up a bit using the TIG welder first. And when I finally got it out, I realized I should have been paying more attention because I took the wrong one out, so I had to go back and take the initial one out that I meant to take out.
We've got Declan helping out today. He's my buddy, shop dog. But we are going to get this thing mounted up on the RMC 1000 right now. So I want to point out again to you guys that the way that our V-style block fixture works is we have these rings that are the correct size for the main diameter, the main journal diameter of the block, or the main bore diameter, I should say. So basically, they will mount on those two surfaces. Then, just like it would have been from the factory, the second alignment that we use for a datum is the pan rail here, this flat surface. And we'll put a triangle in here underneath it. That'll get it so the deck surfaces, when we're done, they come out perfectly square to each other. They come out perfectly parallel to the crankshaft main diameter, or basically to the crankshaft. The only thing that our fixture lacks is an alignment to the cam bore. So what you may end up with is a little bit of, twist there. But really, this is a much better fixture than a lot of people use that just lines up off of the deck surface. In the future, I'd like to improve it, but it's a pretty good way of getting everything square, and we have really good luck with getting all of our deck height the same on both sides as well as from front to back. One other thing on this block, luckily there are no numbers on the deck surface itself that we have to worry about. The identifying numbers are on the front, on the timing cover surface. So luckily we don't have anything here that we have to worry about saving, since this is a numbers matching build. We don't have to worry about saving anything on the deck, so we can go ahead and surface the deck just like we normally would.
As usual, you don't want to forget to take the head dowels out before surfacing, because that can make for a really bad day. This shows a good view of the block resting on the mains there, and me getting that triangle or square into place against the pan rail.
And this is totally kind of a feel thing, just making sure that everything's clean, everything's set up properly, and oftentimes you're going to find some variation, but you want to make sure that it's not excessive, because if it's excessive, you probably have an issue with your fixturing. But everything here looks pretty good. Just double check that everything's tight.
When surfacing the first bank, I run the cutter down until it just begins to touch and zero the z-axis of the digital readout, and I'll often start with about a 2 thou cut from there. The imperfections in this deck surface are really obvious after that first pass, but that's why we're here, so we're going to keep making the cuts until the surface cleans up. At 4.5 thousandths, we're looking better, but you can still see that there's a couple spots that still haven't cleaned. All in all, we ended up taking 8 thousandths off this side of the deck to make it clean up. At this point, I switch over to the boring head and get a cutter set up so that we can bore this side of the block. I'm centering up right below the ridge where the wear in the cylinder is actually the worst, as this gives us the best chance of the cylinders cleaning up at the 30 thousandths oversize we're shooting for. This is pretty much a challenge of just moving the x-axis and the y-axis back and forth until you find that perfect spot where you know that you're centered, because that needle on that gauge is not moving back and forth excessively. It's always likely going to move some because the cylinders don't wear in a perfect circle. Finally, we're setting our stop on the z-axis, which just prevents the machine from going on through and crashing into anything at the bottom of the cylinder. Now, this Pontiac block has valve reliefs on both sides of the cylinders at the top, so it sounds a bit off when you first start cutting. I was also struggling to get the cutting inserts that I had on hand to cut as well as I wanted, no matter what RPM I ran the spindle at. While waiting for the first hole to be bored, I went ahead and got my bore gauge set up so that I could double check my work and make sure that my cutter was set correctly the way I wanted it before moving on to the other 7 cylinders.
Now, oftentimes when you have decked the block as well as bored it, you'll take away any of the chamfer at the top of the cylinder that is left, but as you can see from the factory, these had a ton of chamfer here, so I don't think I even need to come back and put any more chamfer on it because we've got plenty there. We're going to be able to get the piston with the rings installed. I'm not too worried about it, so it's better to just leave it as is.
While the cutters weren't leaving me as nice of a surface finish as I would normally like to get when boring, I was still coming out at a minimum of 3.5 thousandths left to hone to minimum piston to wall clearance, which is about where I like to be. But the issue I was having is that because the cutters were not cutting well, they were generating a ton of heat in the tooling, which was causing expansion, and by the time the cutter reached the bottom of the cylinder, it was giving me around 1.5 thousandths taper from top to bottom, which can be fixed in the hone, but it makes it a much more challenging hone job to get everything to come out right by the time it's finished. But with the first bank finished, we went ahead and rolled over to the other side so that we can get the rest of the cylinders bored and get the opposite bank decked. Again, the fixture is set up exactly the same on the opposite side, and I just double check everything with a level because usually it's going to be pretty close, and if it's not, I probably have something wrong with my fixturing. Now, knowing the way that our fixture works, we can run the machine to the same value on the DRO of the Z-axis so that we get the deck heights at the exact same dimension. Now, we finished on the opposite bank at -8 thousandths on the DRO, and on this bank we had already cleaned up at 7 thousandths, so that last extra thousandths was just the extra that it took to get the deck heights to the exact same value. After that final pass, both the deck surfaces have been surfaced to the exact same deck height on both banks of cylinders, and all of the bores have been rough bored for our 30 thousandths oversized pistons. So we're going to pull the block off of the machine and get it ready to go in the cylinder hole.
We've got a rough board. We know that it cleaned up at 30 thousandths oversized, so we're going to order our pistons. And once we have our pistons in, we'll throw the block in the cylinder hone, and I will finish hone it to the correct size to have the clearance desired for our piston to wall clearance. That being said, we're going to pick up this video on whatever day those pistons show up.
So a day or two later, we had our cast sealed power pistons that we're going to be using in this build. So I just went through and kind of double checked the size on all of them. And that way we can get the block in the cylinder honed so that we can get our cylinders honed to our finished bore size that gives us the minimum clearance of at least 1.5 thousandths piston to wall clearance. Now in the cylinder hone, the block sets on a cradle and it gets clamped down there, and then you can tilt it back and forth to each different bank of cylinders. I'll also set my sun and bore gauge so that 0 on the gauge is my finished bore size that I want to hit. And I use this both doing the sun and setting fixture as well as double checking using a micrometer. Finally, we do our initial setup for the correct stroke rate, spindle RPM, cutting pressure, stroke length, and adjust the height of the block for proper overstroke of the hone. I know those things probably don't mean much to many of you who are watching, but by altering each of those parameters, you can make different fine adjustments to how straight and round your cylinders are going to come out after the hone. Knowing that my cylinders were tighter at the top and looser at the bottom, I obviously wanted to change some of the settings and change the way that I was honing to take more material at the top so that by the time we got to our finished size, our cylinders are perfectly straight from top to bottom with no taper. Here you'll see me running the machine with a bit of finesse in order to purposely hone only at the top of the cylinder for several strokes. To put it simply, when I'm turning the silver wheel at the top of the machine, it increases the amount of cutting action that the stones have on the cylinder. So as the machine strokes the top of the cylinder, I'm turning the wheel up, but immediately turning it back down to avoid removing much material at the bottom of the cylinder. If you've ever seen a newer CNC style cylinder hone in action, you'll notice that they dwell automatically to take care of tight spots in the cylinder. And while I'd love to own one someday, this machine is a bit older and it just requires a bit of finesse to achieve the same result. This was definitely one of the hardest machines for me to learn in the shop, and I don't know if that's how it is for everyone, but for me it's just there's a lot to learn if you want your cylinders to come out perfectly straight, perfectly round, as well as having the right surface finish for proper ring sealing. At this point I'm using a rough stone which removes material quickly and also creates deep valleys in the cylinder wall which hold the oil when the cylinders and the engine are in operation. And at this point I'm just trying to get the cylinders as straight as I can.
Alright, now I've got them all pretty straight, so I'm going to go ahead and shorten my stroke a little bit again, because I think if I keep going like this, I'm going to end up with the top, since I'm overstroking more out the top than I need to, the top is going to end up bigger by the time I get closer to my finished size. So I'm going to shorten that up a little bit and keep on going. Now that I've got everything straight as far as from top to bottom, there's no taper one way or the other.
By lengthening the stroke length of the hone and overstroking further out the top, in addition to the finesse I described earlier, the cylinders had straightened out and we were able to set the machine back to the stroke length of the cylinders and even out the overstroke on the top and the bottom of the cylinder. I also wanted to point out that the needle or load meter you see on the control panel there is running fairly evenly. When there's tighter spots in the cylinder, it puts a heavier load on the machine and thus the meter reads higher. So when your cylinders aren't straight, that needle bounces back and forth very erratically. But at this point it's staying fairly calm as the cylinders have straightened out a lot compared to when we first began.
Are you ready to go home? What do you think? Let's let the block cool overnight, and you and I go home. Let's go get some dinner, buddy. What do you say? What do you say?
As we approach our finished size, I do some material removal with a slightly finer stone as well as a finished stone, and the combination of all three stones sets up the cylinders for an optimal surface finish that will perform and seal well while also having great durability to last the life of the engine. One last step I like to do while it's in the hone is run a hone through the lifter bores very lightly, as well as using a soft plateau hone on the cylinders, which removes any microscopic defects left behind from the honing process which would otherwise break down almost immediately inside of the engine on initial break-in. And with that, the block is ready to go in the spray cabinet for its final wash before it's ready to be prepped for the final assembly of this engine. I like to run one complete cycle before rinsing and brushing the cylinders out, which I find really helps remove the debris left in the cylinders from the honing process. And it's important to note here that this brush is extremely soft and has no abrasive properties, and it does not affect the surface of the cylinders whatsoever. After the second wash cycle is complete, I've rinsed the entire block extremely thoroughly, as it is critical that there is not a single speck of debris left in this block as we prep it for assembly. This means I rinse every single hole before using the compressed air to blow every single hole and passage out of this block. The first thing I did to prep this block for assembly was get those dowel pins back in that help align those main caps. Before installing any cam bearings or any oil galley plugs, I run a brush through every single oil galley in the block and again blow it out extremely thoroughly again. We use Durabond cam bearings almost exclusively in the builds that we do here in the shop and have really good luck with them. These bearings have 3 holes in them. I'm assuming for other applications that they fit, but this particular block only has 1 oil hole in each cam journal, so you pretty much just choose one and make sure that that one's aligned and go from there. I would say in most cases there's not really a right or wrong direction to put the cam bearings in from, but I like to look at the block, and a lot of times they're chamfered on one side or it's a little bit less of a sharp edge from one side or the other, so that's why I'm putting the cam bearings in from the direction that I am. And if at all possible, you should use the tool like I show there, because it has a cone on the front of it that helps you get those bearings in straight, whereas on this front one I just had to make sure that I had it aligned very well. Whenever possible, I like to test fit the cam as soon as I put the cam bearings in, because it's just a pain in the butt when you find out later on that your cam bearings are a little bit too tight, and you have to go back and try to figure out how to get everything to turn well. So that's why I put the cam in right away and make sure that everything fits well and everything turns. From there, you're pretty much on the home stretch. We put the coolant plugs in, we put the oil galley plugs in, and we put all of the freeze plugs in. And I like to put the freeze plugs in with the numbers facing up. That's what my dad taught me. It just looks a little bit cleaner when you've got an engine with all the freeze plugs in the same way. You know, just the OCD stuff that Dad pushed onto me. If you're not completely familiar with all the oil passages in a particular block that you're working on, you just gotta really look it over and make sure to get every single plug in where it's supposed to be, and you know, just make sure that you've got them all, because you don't want to miss something like that. When you're putting in smaller plugs like this, you can always find a socket that fits perfectly, but do not let the boss see you doing this, because it'll just piss him off. And with that, we've got the block board 30 thousandths oversized. The decks are surface square and to even deck heights, and it came out beautifully, so I can't wait to get this thing on the engine stand and start getting some new parts put in it. Thank you all for watching. Hit that subscribe button if you're not already. Give it a like, drop a comment letting us know that you enjoyed, and we'll see you in the next one.